Welcome to Bestech Clean Energy's presentation on biomass waste to energy gasification. Bestech Clean Energy is a developer that specializes in renewable energy, waste to energy, and electrical power generation through the use of gasification, incineration, and solar photovoltaic technologies. We offer three types of renewable energy plants: waste-to-energy incineration, waste-to-energy biomass gasification, and commercial photovoltaic solar systems. Our presentation today will be on our biomass gasification plant. We have the capability to design, develop, build, and operate biomass waste-to-energy plants for you. In this presentation we will go through the various requirements and steps needed to go from design to an actual working biomass-to-energy plant. There are three primary methods of handling solid waste, with multiple variations for each type. The first is landfilling. Landfilling has been the most common method of disposing of waste for many years. However, landfills have become both overburdened and sources of pollution. Landfills can cause ground contamination and air pollution from the decaying solid waste. The second method is composting or biodigesting of the solid waste. Composting or digesting uses bacteria to allow the solid waste to decay and give off gas, primarily methane, which can be used to make energy. Composting or digesting of the solid waste is limited in the types of waste that can be processed. The third method of solid waste processing includes gasification, incineration, and pyrolysis of the waste. Incineration actually burns the waste materials to create electricity. Gasification and pyrolysis create a clean synthetic gas and combust that gas to make electricity. There are advantages of waste-to-energy gasification over other methods of waste disposal. The first is the land usage needed for each type of solid waste handling. Landfilling can take large amounts of land space, whereas composting and gasification do not. Untreated biomass solid waste can leach into the ground and cause water pollution. It can also create air pollution from the methane and other gases that it gives off as it decays. The initial investment in gasification is higher than biodigesting or landfilling. However, potential environmental problems can make landfilling of the waste actually cost more than the initial investment in the landfill. Operating costs for a biomass landfill are lowest of the three methods. But again, potential environmental problems can make operating landfills or composting facilities much more expensive. The biggest advantage of biomass gasification is that it can reduce the volume of the waste materials by 80 to 90%. Properly treated, the bottom ash from the process can be safely disposed of, used in construction, or used to make biochar. What are biomass materials? Biomass, sometimes referred to as green waste, can include wood chips, plant waste, food waste, trees, or some other plant materials. Any materials containing carbon can be gasified. The proposed gasification plant would use these biomass materials as feedstock for the gasification process and to make electricity. What is the gasification process? Gasification differs from incineration in that the waste materials are not burned. Oxygen is required for combustion to take place. For gasification, the biomass waste materials are heated to high temperatures in a low oxygen atmosphere, which breaks the materials down into ash and a process gas called syngas. The syngas consists of carbon monoxide, carbon dioxide, hydrogen, and a small trace amount of methane. The syngas, rather than the biomass solid waste materials, is combusted to create electricity in the gasification process. Using the syngas, rather than burning the waste materials directly, makes for a much cleaner process. The gasification process is also a more efficient process than incineration of the waste materials. Some of the benefits of biomass gasification are that gasification is capable of processing a wide variety of feedstocks, including biomass waste such as wood, wood chips, plants, trees and mulch. Using biomass as a feedstock source to create energy prevents an equivalent amount of fossil fuels, such as coal or natural gas, from being burned to make that same energy. Gasification of biomass waste can be considered a renewable energy source. Biomass materials are continuously being produced. Gasification plants can be scaled in size based upon the availability of biomass waste materials. The facility size is determined by the amount of biomass waste that can be processed. The syngas from the gasification process is passed through cleaning processes to assure that emissions from the plant are cleaned of hazardous materials and particulate. Gasification facilities can be constructed close to the participating communities that they will be serving. A gasification plant would mean new permanent jobs needed to operate the gasification facility, as well as construction jobs needed to build the plant. Here are two examples of actual operating biomass gasification plants using the design that Bestech Clean Energy is proposing to you today. Each plant is customized to suit the customer's needs. One is enclosed in a building. The other is without an exterior building. Where climate conditions permit and to reduce cost, a gasification plant can operate without a building shell. Each plant is custom designed to suit the customer's needs. In front of the whole process is a highly efficient material drying and shredding system to ensure the correct moisture content and processing size of the waste materials. The gasification process begins with the biomass waste materials delivery to the facility. Acceptable materials are trees, plants, vegetation, wood chips, mulch, and some construction wood waste materials. There will be a scale at the facility so trucks can be weighed as they arrive at the facility, both incoming and outgoing. The waste weighing data will be uploaded to the plant control system. An intelligent management system is used for the stocking and feeding process to ensure effective combustion and maximum heating values in the gasifier. The incoming solid biomass waste materials will be shredded to a uniform size for processing with a double-shaft industrial shredder. Consistently sized biomass waste materials will make for better heat values in the gasifier. Here are diagrams of our material drying systems that can be used for biomass waste drying. The drying system is customized for each gasification plant design. Many biomass materials, trees, and plants, contain moisture. The gasification process works optimally when the solid waste materials are dried. Moisture present in the solid waste materials can lower the heat values that can be obtained from the waste materials. So, the shredded materials are sent through a drying process to reduce the amount of moisture in them. By drying the materials before sending them through the gasifier, higher heat values are achieved in the gasifier. This results in better electrical power output from the turbine generators. Some mixing of the biomass materials takes place in order to get a balance in the feedstock going to the gasifier. Drier materials will be mixed together with materials containing moisture to get a more homogeneous feedstock to be processed. Here is a process diagram of our gasification system. As you can see, there are four main systems that make up the gasification process. There is the biomass gasification system, the steam boiler system, the dust and ash collection system, and the steam turbine generator system. The exact gasification system design and plant configuration will be customized for your specific needs. The plant is simple, modular, rapidly constructed, and comprised of field-proven components and technologies. Here is a design image of a gasification plant without an exterior building. In more moderate climates and to keep the investment costs lower, a plant can be designed and constructed with no building. Our system offers efficient power generation through improved heat recovery, improved steam turbine efficiency, and reduced plant power consumption. Here are images of the steam boiler and turbine generators for our process. Locally generated power can reduce transmission line losses and distribution system congestion, making the system more efficient. Local companies and labor will participate in the construction of the facility. The plant will deploy modern gasification and power generation technologies for the conversion of biomass waste into electricity. Gasification is a proven technology that holds great promise for alternative energy and is at the core of a number of bioenergy and biofuels programs. Here are some of the typical customer requirements analysis done during the design process. We look at environmental benefits requirements, and social benefits requisites. We also determine the syngas cleaning requirements, water resource recycling utilization, and ash disposal methods. We also take into consideration safety and reliability requirements of the project, as well as the economic forecasts for the project. Our plants are designed to operate more than 8,000 hours per year and have a life of over 30 years. They are very efficient in thermal conversion and power generation. Other considerations to be taken into account are biomass availability, land or site location and surrounding area, makeup of the solid waste materials, water conditions, and interconnection grid requirements. Project studies will be done to determine all of these factors. Here are plant design considerations. They include boiler design, electric control system design, architectural requirements, waste drying, sorting and shredding, and the best water treatment system to be used. There is a custom project design plan for each customer project, to meet their needs. There are a number of tree diseases such as citrus greening, spread by insects, which are causing problems, and citrus crop losses in Florida and other citrus growing states. Gasification of the biomass waste would be an effective method of disposing of plants, trees, and insects with the citrus greening disease, HLB. In early stages of the infection, it is difficult to determine if the citrus disease is present. Currently, using mulch infected with this disease can promulgate the disease to other trees and plants. Gasification, rather than mulching or wood chipping, will be an effective means of destroying infected plant and tree waste and the insects that cause the disease. Bestech Clean Energy. Bringing the best available biomass gasification technology to meet your needs today and for your future waste handling demands. Our contact information is below.